All right, so 8.6 is integration using tables. So in the back of your book, you have something called Appendix B. And Appendix B is on page A21 to A24 in the back of your book. So it looks, is everybody finding it? Did you guys get there? Looks like this. And you have 1, 2, 3, 4. You have 4 pages of possible formulas that might be helpful in certain situations. So just take a peek through those first. And so you can see that some of them you're going to see are things we've done. Like the very first one. U to the n du is u to the n plus 1 over n plus 1 plus c. Well, you already knew that. I mean, really, do you need a table for that? No. But there's some as you work your way through that you're going to be like, oh, I could use this table if that were part of the problem or if it allowed me in the problem to do so without having to use integration by parts or without having to use U-substitution or whatever. There's that going on. There's also some in here that you're going to see that we haven't dealt with at all. We haven't done anything that looks like this particular problem at all. Okay? So let me show you how this works. One of the things that you will need to do for me is that if you're using tables, and particularly in this section, is I want you to tell me which formula it is you're using. Okay? Because sometimes there's more than one option. And also, if you've identified a wrong formula, then that's an easier thing for me to look at and say, oh, they got the wrong one because, look, there's a plus sign and they thought it said a negative or they overlooked that piece. And that's why everything's going amok. Okay? So you're going to identify which number it is of the table that you're using on that particular problem. All right, so taking a look at this one, we've got 1 over, we've got x squared on the outside, we've got the square root of 1 minus x squared on the underside of the square root. And this one actually should feel a lot like section 8.4 that you guys just did. I mean, it looks like it, right? We've got a square root, we've got factors that are squared, subtracted. I could probably use some trig stuff to do this. But in this section, we're practicing using tables. So I want you to look through your table and see if you can find something that actually matches up to this right here. 35. 35. Is it 35? Oh, it looks pretty good, doesn't it? 35 has 1 over, it has a u squared out in front. Well, if u is my x, that sort of looks like my x. And it's got a u squared and a plus or a minus an a squared underneath. Well, that looks pretty good, doesn't it? Almost. There's something off about it.
Did the A and the U are flipped?
Yeah, the A and the U are flipped, which is problematic, isn't it? So try again. It looks awfully close. Is there another one that looks close? 44. Okay, so I've still got that u squared on the outside. That's good. But now on 44, I have the a squared, the constant first, and the variable second. So that's the one that's going to match. But do you see why, Parker, then, that by identifying 35, I'll know, oh, they didn't notice that these are actually reversed because, believe it or not, I know you still think that A and U are letters, but they're really not, right? You guys know that, right? A is a number and U is a variable. So, okay. So as you're using your integration, you're going to write down which table you're using. So this is your table value in number 44, right? And as you're doing this as well, let's identify what U and A are and match them up. So what is U in your problem? Yes, it's X. And what is your A in your problem? 1, right. So then you're going to read the right-hand side of this table, and the right-hand side of this table simply tells you the answer. Raise your hand if you think you need a back of the book. Well, at least this part of the back of the book, right? This would be great. But it tells you the answer, doesn't it? But in a general form, once you've identified your U and your A. All right, so we actually have our solution on there. So we have a negative on the outside. It has a square root. It says a squared minus u squared. Well, what is your A? 1. So 1 and 1 squared is 1. Minus, what is your U? X. This is minus x squared. We're going to write this over, and then on the denominator it says a squared u. And your A was 1, and your u is x. So this is over x plus c. And you're done. Who likes 8-6? Okay, that's what I thought. Any questions on that one? Okay, let's see if we can get something else. They're not all that direct, but they all have some of that going on. Let's take a look at part B, letter B or whatever, problem B. We have 1 over 1 plus e to the 2x dx. 84. See, I don't have these written down in mine, so let's take a look together. Is 84 going to work? Looks pretty good, doesn't it? It has 1 over 1 plus e to u. So if that's the case, what is u in your problems? This is table, in the table we're at number 84. What would your u be?
2x.
2x, which actually means that in order to do this problem, you're going to have a du, which is 2 dx. So I'm going to actually take this problem and I'm going to do it with the u-substitution like we would actually have seen before. This is the 1/2 out in front, right? Times the integral of 1 over 1 plus e to the u. The nice thing about it, of course, though, then, is that it really exactly matches page 80, table 8, number 84 in the table. So we go to the right-hand side, and the right-hand side says that this is, I've got my 1/2 out in front, is u minus the natural log of 1 plus e to the u, and then all of this has a plus c. And you could have put the u in that step if you'd wanted. If you didn't already, like I didn't, sorry, it disconnected, just a sec. If you didn't already, like I didn't, then you would put it in at this point. So this is actually 1/2 of 2x minus the natural log of 1 plus e to the 2x plus c. And we're going to distribute that through because that just has so many unnecessary parentheses. I don't know about you, but it does to me. 1/2 times 2x is x, and then I've got minus the 1/2 natural log of 1 plus e to the 2x quantity plus c. There's one thing you could do. I'm fine if you leave it like this, but if you were sort of checking something online or you were checking the back of the book, what else might they do on this problem? Yeah, they might take that 1/2 that's in front of ln and put it as an exponent. What else might they do if they put that 1/2 as an exponent? They might write it as a square root. So an alternate form of this might actually look like this. Everybody with me on that? You don't have to do that. I just want you to recognize that if you see something else that doesn't quite look like yours, especially with logs, there just might be some additional property of logs that they've used to do that. Okay, ready for the third one? Cosine of x over the square root of sine of x, or sine squared of x plus 1. Okay, so Caesar, this one's a little harder just for you because you asked. You gotta find something that looks like this. Which one? Did somebody find one? You guys are awfully quiet. Got 4 pages of tables to look at, right? You won't need to use 2 separate ones.
31.
But you may have to use u-substitution like we did in the last problem. Which one do you think it is, Jordan?
31.
31. Let's take a look. Yeah, I think 31 will do it. But if you look at 31, everybody look at a book next to you. If you don't have one with you, I want you to please find somebody that's nearby enough of you that you can look at their book. 31, maybe I should just write it on the board. 31 says, what you're identifying this to be is the integral of 1 over the square root of u squared plus or minus a squared du. Jordan, you're right. That's the right one. But why in the world would you think that's the right one? Because it doesn't really quite look like, I mean, where's the sine? Where's the cosine? What's going on?
When you make the u sine, you have u squared plus 1, which can be a squared. And then when you take dx and the du, you have to replace the cosine.
Very good. One of the things to notice when you've got trig functions involved is that if one of them is u, then likely when you take du, it's going to be the other piece. And sine and cosine have that relationship, right? That, I mean, they may have a negative involved depending on what you're taking the derivative of, but they're each other's derivatives, right? Sine and cosine, they go hand in hand. They go back and forth all the way, no matter how many derivatives you take. So if I have u as sine of x, then I've got the u squared plus 1 underneath the radical that I needed. And then the du is the cosine of x, which is exactly what's on the outside that's not sort of taken into account when I looked at number 31. Are you guys following? So that's what's happening on that one. And that's a little trickier, right? And that's not quite as clean as the last one. It's certainly not as clean as the first one. All right, so as we're taking a look at this, let me go ahead and rewrite it with the u substitution in there, and then we'll identify all the u and the a and all that stuff. So I've got the integral here. The cosine of x dx, there's that, sorry about that, is the du. So I can write 1 on top, or you can write your du on top. And then if sine of x is u, then this is u squared plus 1 in the denominator.
What number was this? Was it 30?
It's number 31 from your table. So we have already said that the u is sine x. What is the a in this problem? The a is 1 because it's 1 squared at the end there. The other thing to notice is that this is identified as plus or minus in the formula, which means then as you look on the right-hand side, you need to make sure it's really also plus or minus on the right-hand side. On some of these table ones, you'll notice that on the left-hand side, it'll say plus or minus, and then when you look at the right-hand side, it'll change and it'll have a minus or a plus, and it'll do like that. So if it was plus to start, it's minus to end. If it's minus to start, it's plus to end. This one doesn't have that, but just be aware that that happens sometimes. This one, the order stays the same. It still has the positive on top. So because our problem has a positive in it to begin with, it will have a positive in it as our part of our answer. So then using the table number 1, I've got the natural log of the absolute value. I'll just identify exactly like they've got. U plus the square root of the same square root I have, so it's u squared plus 1, because a is 1. All that plus c. And then, of course, I need to put my u back in, right? Sorry, guys. So I don't like using this is because I disconnect it too frequently. And so then u is sine x. So this is the natural log of sine of x plus the square root of sine squared of x plus 1, and then plus c. That's really all there is to using tables. It's just about as complicated as it gets. Okay?